In this lesson, we are going to use composition of linear functions to verify inverses by composition. So if two functions are inverses of each other, then g of f of x should equal x, and f of g of x should also equal x. And we're going to understand this more by doing this example here. So here I'm supposed to find the inverse, so I'm going to just follow the steps we followed in the last lesson. So we have y is equals to 2x minus 3. I'm going to add 3 on both sides. So I get y plus 3 is equals to 2x. And now I'm going to switch x and y. It doesn't matter which step you switch them. It works all the same. So we get x plus 3 is equals to 2y. And then all I need is to divide everything by 2, and that means y is equals to x over 2 plus 3 halves, and I can write it in notation form. So x over 2 plus 3 over 2, and that's the answer right there. The next step is to verify by composition. So what I'm going to do, I need to find f of g of x, and maybe you're asking yourself, where is g of x? So what I'm actually doing, I could use any variable. I'm going to call this g of x. So here I'm going to have f function. I take the f function, which is 2. Instead of x, I'm going to plug my g of x, which is this function here, which is going to be x over 2, x over 2 plus 3 over 2, and then I'm using f of x minus 3, so I get, see, when I distribute the 2, this is 2x divided by 2, which is equals to x, and then 2 times 3 is 6 divided by 2, so plus 3 minus 3, so I get x. And then I'm going to do g of f of x. So g of f of x, so I take the g function, and the g function is the one which was the inverse in the previous case. So instead of x, I'm going to plug in, instead of x, so I'm taking the g of x, but instead of x I'm going to plug in 2x minus 3 over, I'm actually going to, let me move this one over here. So this is going to be 2x minus 3, everything is over 2, and so I'm plugging the over 2 plus 3 over 2, and I want you to note that this is the same as 2x over 2 minus, I'm running out of space here, minus 3 over 2 plus 3 over 2, and see, this is going to cancel out, and I'm just left with x. So that means, since I have gotten x in both cases, that means they are inverses of each other. Let's do another example. And here I'm going to do, because my problem is here in the middle, I'm going to do, let me start, I'll do it on both sides here. So here I do, remember this is h of x, just another name for the function, but it doesn't matter. So I do f of h of x, which is going to be, I take the f function, so 1 over 3, and then instead of x I'm going to put 3x minus 20, 3x, so 3x minus 21, and what do I get? 1 plus, I should not forget, plus 7. See, when I simplify this, this is 3x divided by 3, which is x, 21 divided by 3, minus 7 plus 7, so I get x. And then I'm going to do h of f of x. So I take the h function, 3, and then instead of x, I'm going to do 1 over 3 x plus 7, and then minus 21. So what do I get? I just continue here. So 3, when I distribute, 3 times 1, so x plus 21 minus 21, which is equals to x. That means both of them are inverse functions. Why? Because f of h of x is equals to x, and I also found that h of f of x is also equal to x. So here, because I got these two, and see those two are true, so I can write here verified, and that's how we verify. One misconception I usually see a student just doing one of them, just f of g of x or whatever variable you have, and then stopping there, but you have to show both ways.